To building your own widget with the ArcGIS JavaScript API. I'm Matt Driscoll. I'll be co-presenting with Juan Carlos Franco. We are both software engineers on the JavaScript API, and we build the widgets in the API. So the agenda for this session, we're going to show you how to set up your development environment. We're going to cover some widget fundamentals. Then we're going to develop a custom class in our API. We're going to then create a really simple widget. And then we're going to create a custom widget using the class we developed in the first demo. And then we're going to go over some additional improvements you guys can make to widgets. So first, setting up the dev environment. So the development environment is going to be composed of the JavaScript API and TypeScript. And TypeScript basically just adds types to the JavaScript language. And we're going to show you guys how to install it locally for your project. So about type JavaScript, in this example, I've created a type or an interface for a person. And I've said that a person has both a name and an age. And the name is a string and the age is a number. So this way I can create a constant called person, and I can say it's of a type of person, and I can define that, and it needs to match what I've defined up here. So I've given this person a name of Franco and an age. So this is nice because if I try to do something invalid, like say person's age is a string of 24, TypeScript will let me know that that's incorrect because I've declared the age to be a number. And also if I try to do person.height equals 5'11", the property height doesn't exist. I haven't declared it on here, so it's going to let me know about that. And this is great because you can find bugs real easily or prevent bugs from even getting in your code. So in this little example function, I take an argument person as a type of person, and then I can log their name in a string. So if I call greet person, it's going to say hello Franco. So we'll be using modern JavaScript in this example too. So things like let as a variable that can change. So I can redeclare this variable from like 5 to 10 or whatever number. And we'll be using constants, things like, cannot change. So once I set this constant to 5, it will be 5 and we can't change it. We'll also be using fat arrow functions for easily creating functions. We'll also be using template strings, so we can easily insert variables into a string. We'll also be using destructuring, and it's just basically an easy way to unpack values into variables. And we'll also be using a shorthand property. So instead of saying, person colon person, I can just put person there and it'll automatically do that for me. As far as IDE support for TypeScript, pretty much all of them, all the web JavaScript IDEs support TypeScript. We'll be using Visual Studio Code, but you can use something like WebStorm, Sublime Text, and a bunch of other ones. So we'll be doing that. We'll be setting up TypeScript. So this is Visual Studio Code. And let me just explore the file structure here. So we're in our setup demo. There's an app folder and there's an index page. And the index page is basically just setting up using the next version on the CDN of our JavaScript API. We also have a really simple style sheet just to style the map div. And then we're setting up our apps packages so we can have a custom package for finding our demo files. And this is going to look in the app folder. And this is the next version of our JavaScript API. Here's where our view is going to be placed. And then we're just requiring the main file for our demo. So if I look at that, that's that right there. There's no code. So if we look at our demo page, it's basically just a blank page and nothing's going on. So let's set up TypeScript in our IDE. So the first thing we're going to want to do is go into our project directory open up the terminal. This IDE has a terminal built in, so we're going to use that. And first thing we're going to want to do is do npm init and --yes. This is basically going to initialize the project with defaults. So it'll create a package JSON, and that will have all the defaults for your project that npm is going to use. The next thing we're going to want to do is install TypeScript and the typings for our API. We'll do this by using npm install. We're going to save it to developer settings in our package JSON, and we're going to install TypeScript and the types for the JavaScript API. So the types for the API are just to let JavaScript know about the things that it can do with our API, such as like what functions and modules exist and how they're used. So that will basically create that in your package JSON so that you can do npm install and get that stuff. Then we're going to initialize TypeScript. This will create a tsconfig file, and we've already set up with our settings, but this will be a little different, and you can go to the page I showed for setting up TypeScript and grab the configuration you'll need for that. And we can do this by doing npx tsc-w, and this will basically compile TypeScript, and it'll watch the files in this project for any changes and then recompile TypeScript as it needs to. So it's starting TypeScript in watch mode, found 0 errors, cool. So now our project is up and watching files and compiling. So if we go back here, we can see there's still nothing happening. If we go into our IDE in that main file, what we can do is uncomment this code. And so this is going to recompile, and it's going to import the Esri map and the map view. It's going to create a map with the streets vector base map, and it's going to create a view using that map and then using the view div node in our HTML, and it's going to set it at a center location and a zoom level. So recompiled, and if I go back into this file and reload, we should now have a map. So very basic setup on how to get TypeScript going and create a really simple application. So just to summarize that, what we did was we installed TypeScript and the JavaScript API typings, and we built a really simple mapping application. Now let's create a class. So all the classes in our API extend Esri core accessor. So this is the foundation of our API. And by doing that, we get a consistent developer experience. So all the classes that inherit from this have a similar functionality to them. Here's how we would create a class extending accessor. So in this example, we're creating a class of person. It extends accessor. And we're using the property decorator, saying, okay, this is a property of name, and it's a type of string. And by using this decorator, we get some benefits that we'll go into in the next few slides. And we're also creating a property of age, which is number. So as I showed earlier, you can create a constant of self, which is a new person, and their name is Franco, and their age is listed there. So one of the benefits of accessor is that each property can be watched. And what that basically means is I could watch name or age for any changes and then get notified and call some function like happy birthday, right? So this watches the age and then calls happy birthday. I can also alias properties. So for example, if I want another property called years alive that aliases the age property, I can do that so that when age changes, this property also changes. So it's just a nice convenience thing to do, be able to link properties basically. And so this would basically log the same thing as age but in self.yearsalive. Another advantage of accessor is autocasting or easy class instantiation. So in this example, I'm creating a class called house, and it extends accessor, and I have a property type of person, and it's called owner, and the type of person. So in this example, I can create a new house, and I can say there's owner is, and notice how this is an object. So it's an object with the name of Franco and age 33. The nice thing about that is when I instantiate this, it'll automatically type this object as a class of person. So it's just a nice convenience thing to not have to say new person here. You can just use an object. So a little bit of background about the custom class we're going to create. It was inspired by this layer effect sample. So let's check that out. And basically, this sample allows you to apply a bloom effect to these volcano points. So if I turn it on, I can adjust the value of that bloom intensity or radius and threshold. So what we're going to do is we're going to create a custom widget that allows you to apply all different kinds of effects to a layer. So the requirements for our custom class is going to allow you to configure a layer's effects. And as you update that layer's effects, it should be applied to the layer. So let's look at the layer effects API. So right now I'm looking at the feature layer class, and it has an effect property on it. And this is what you would set as a string to say what kind of effects should be applied to this layer. And so, for example, it's very similar to CSS effects. So for example, this image right here looks like that by default. I could apply a blur effect and it gets blurred out, or I could adjust the contrast of it, make it grayscale, rotate some of the colors, or add a drop shadow. So those are the kind of effects you can do that are very similar. So for our custom class, this is the API design we came up with. So we're going to create a custom class called LayerFX, and it's going to extend accessor. And it's going to take an argument and have a property of layer. So a user would pass in the layer they want to apply the effects to, and we would store that as a property. And then we'll have a couple of read-only properties that the user won't modify, but will be generated for them. And this will be the effects, which will be a collection or fancy array of a custom class we're going to create called LayerEffect. And we'll go into this in a second. And it's also going to compile the statements for each effect that can be applied to the layer. So this will ultimately get applied to the layer.effect. So in our custom helper class, we're going to have a property of enabled, which will be either true or false. And by default, we'll have it false. And then the user would supply whether or not it's enabled and the ID of the effect. So this can be bloom, blur, or a number of other ones. And it can apply an array of values for that effect. For some effects, it may just be one value. And for some like bloom or drop shadow, it needs a few different values. And then we'll have a read-only property of value types. So based on the ID of the effect, it's going to supply the unit for that effect and the number of values it needs. And we're also going to have a read-only statement string, and this will be generated based on the values and the ID and the units. So let's start creating this. The first thing I'm going to do is open up this basic custom class page and open the console. Then I'm going to go into our IDE and open up the custom class demo folder. And again, it has a very similar HTML page. The only difference is we're configuring a couple packages here. Otherwise, it looks exactly the same. So we'll go into our app and open up the main TypeScript file. In here, what we're doing is we're importing map view, feature layer, and our two custom classes which we're going to create. And then we're setting up our feature layer and this feature layer is going to show the latest 14 months of unemployment statistics. And we're going to create a map with a dark gray vector with our feature layer inside of it. We got our map div using the map at a location. And then we're instantiating our custom classes, the layer effect and the layer fx. And then we're adding those variables to the window so we can reference them easily via a global variable. So the first thing we want to do is look at our layer effect class and our layer effects class. And so the layer effect, this is probably the most basic minimum required you need to create a class in 4X. We're importing the accessor class, and we're importing the subclass, and we'll eventually use the property decorator as well. So we're giving this class a name of layer effect in our demo folder. And this class is extending accessor, and we're exporting it. So very simple. So the first thing we're going to want to do is add a lifecycle to this class. We're going to do that by adding the lifecycle inside the class here. And this will take a number of properties, which should be layer effect properties. And you'll notice that TypeScript is giving me an error there because it doesn't know about this. So we need to import the dependencies for that. So we're importing an interface, layer effect properties. And basically what that is just defining the kind of properties that are needed for this class. So this can have an effect ID, which could be a number of these different effects. It can have an array of value numbers and whether or not it's enabled or not. So now that I imported that, the error went away. And we're also importing a helper class. And this is going to give us the different values we need for depending on the ID of the effect. So for bloom, we're going to need a few different values: strength, and it's going to be a percentage, radius, and threshold. Cool. So now we're going to start adding properties to our custom class. And I'll do this by pasting them in. So we're going to create another section, properties. And so here we're going to first create a property of enabled. And this property is going to be false by default, but a user could change it so that it's true at some point. And once it's true, it's going to start making that effect apply to the layer. Then we're going to import or create an ID property. And this is going to be the layer effect ID. And you'll see that TypeScript needs to know what that is. So we're going to import it from our interfaces. And then we have a property of values. So this would be, things like determining the intensity for the bloom and stuff like that. By default, this would be null, but a user would set an array with different values for depending on the ID of the property or the ID of the effect. And then we have our value types, which will be generated. So it's read-only. It'll be generated based on the effect ID, and it's using this effect value type interface. So we'll import that, and I'll show you what that is. So this value type is going to potentially have an ID. It's going to have a min and a max number, and then a unit assigned to it. So whether to use percentage, degrees, or pixels. Cool. And then we have that using that utility we imported, so get effect value types, and it's going to get the unit depending on the ID. And then we have our statement property, which is also a read-only property. And this is going to return a string. And it's basically going to get the template, get effect template based on the ID and the values of this class. So we need to create this method to do that. So we're going to add a private method called getEffectTemplate. We'll create another section for private methods. Create that getEffectTemplate template method. And what it's going to do, it's going to pass in an effect ID, which will be a string, one of those values right there. And then the value for that effect, which could be a number of values. And it'll create a statement that looks something like this, depending on which values are defined. So it may just be one or maybe a few. And it's going to use a template string to get the value and the unit. And it's going to join those with a comma. And then we're going to create another template based on that statement right here with the effect ID. So it'll look something like bloom 50%, 12 pixels, and 50%. So cool. That's our layer effect class. Now let's go into the layer effects class and set that up. So again, what we're going to want to do at first is set up the lifecycle. And this is going to take in properties of type layer effects properties. So we want to import that as well as some other imports we're going to need. So we're going to import the layer effects properties, which basically just takes a layer, which is going to be an effect layer, basically any layer that has an effect property on it. Cool. We're also importing the collection, so we can use that for one of our properties. We're going to import a handles utility to watch our handles and remove them when we don't need them anymore. We're using the watch listener from watch utils, so we can watch a property and then do something when it changes. And then our custom class we just created, layer effect. We'll be using that. So let's create this collection we're going to need. So this is going to be a constant of layer effect collection. It's a collection of type layer effect. So basically it's just a fancy array of layer effects. We're going to add a variable for our handles, and this will allow us to manage our listeners and remove them when this widget is destroyed. And then let's add our properties. So we're creating a new section for our properties. And the first property we're going to create is the effects property. And this is going to be a read-only property, so users won't set it. It'll be generated for us. And it'll be a collection of layer effects. So what this is going to do is it's going to create a collection of layer effects, and it's going to create a layer effect for all of the IDs that we have with their default values. So we got bloom, blur, brightness, contrast, all the way down. And then we need to import this type of layer effect collection, which is just a collection of layer effects. So we'll do that in our interfaces here. Cool. The next property we've set up is layer, and this is going to be an effect layer. So this is what the user would pass in, which layer it wants to apply the effects to. So we're going to import that effect layer interface as well. And you notice it's recompiling every time I make these changes. And then we're going to set up our statements property, which is also a read-only property. And this basically looks at all the effects we have in this class, and it's going to go through them and just get the ones that are enabled, and it's going to grab their statement into an array, and then it's going to join them with a new line. So this basically is running through our effects and creating a string of all the statements of them. So we have our properties set up. The last thing we need to do is add our listeners, and we're going to do that by going back up to our lifecycle and then adding an initialize lifecycle method, which is going to set up our handle to watch the statements property. And then if that statements property changes, it'll look at the layer and set the effect to the statements. So this will basically do what this is saying right here. It'll say layer effect equals, and then whatever many statements are there, it'll apply it to the layer. And then we've also added a destroy lifecycle method so that when the widget, or I mean when the class is destroyed, it'll remove any handles that are there and destroy the handles listener. So what we're going to do is go back into our page, and since this has been recompiling the whole time we've been building it, it's good to go. The first thing we're going to do is go into the console and access the layer effect through that global variable that we set up on the window. And I can look at the layer effect and see that it has the properties that I set up, such as enabled, ID, the statement, the different value types for that statement, and the values. So cool, that class is working. Let's check out the layer effects class. So here I have the effects collection with all the different items that are in there. I can look at one and see that, okay, it's got enabled false by default. It's bloom. There's a statement. It's got the 3 different value types, strength, radius, and threshold, and its different units. And then the different values it has, which are all 0. Cool. So we want to make sure that this statement is working correctly. So what we want to do is we're going to look at the layer effects and get the first item in that collection and set it enabled to true. And we're going to set its values to 10, 20, and 30. So you notice as I did that, it applied the new effect on the layer. So if I look in layer effects, I can go into the effects collection, look at the items, go to the first one, see that this one is enabled now. It's a bloom. There's its statement with the values we supplied, and there are the values. And then if I look at the other properties on this class, I can look at the layer and go into its effect property and see that it has the effect applied on that layer. So that's good. There's its statements, and everything's working. So sweet. So we can see that our class we set up is working correctly. Just to recap what we did, we created a layer effects class. It implemented layer effects and the supporting class layer effect, which both extended Esri core accessor. We created some properties using the property decorator. We typed constructor arguments, and we created some methods. Now, with that, I'm going to turn it over to Franco, and he's going to talk to you about writing a widget.
So in this next section, we'll be learning how to write a widget. But first, let's just recap what widgets are. They are small pieces of UI. They are created to perform a single function or group of functions. They are interactive and stateful. Why would you want to use a widget? Well, mostly it's because it's reusable, meaning that you can author once and then just easily bring that widget into another application or share between multiple parts of an application. They are modular, meaning that each one can tackle a specific piece of a concern or interaction, which allow you to create building blocks of bigger interactive experiences, and thus help you build more complex apps by bringing all of these different widgets together. So how would you go about in creating a widget? Well, in the JavaScript API, we do that by extending the base widget class. It extends Esri core accessor, which you learned about in previous slides. And by doing this, we get a lot of the benefits from accessors, such as properties, watching these, aliasing, etc. It also allows us to define a lifecycle that you can use for more consistent development. For a widget, the lifecycle consists of the following methods. Constructor, which gets called as soon as you create your instance. Then comes post-initialize, which is where you will be wiring up the main logic of your widget. Then there's render, and we'll talk more about that in the following slide. But this is where you will be defining your UI. And related to this one, there's also the when method, and it fires after the first render. Then there's the destroy method, which is where you can define logic to clean up all your widget's resources. So the render method is where you would be defining the look and experience of your UI. It is meant to react to state changes. So as you define properties and interactions, you modify the state of your widget, and then your UI gets updated. Another key aspect is that it uses JSX, which is a syntax that looks very closely to HTML and is powered by a virtual DOM system, which abstracts away a lot of the logic to create and maintain DOM nodes. One of the recent changes that we made is that as you are updating properties, the widget will automatically re-render. This makes development much easier than before. So let's start off by creating a simple widget. We'll be creating a widget with an enabled property, and then in the widget's UI, we will be rendering the state of that property in the form of a button. So let's move on to our demo. Here's a little preview of what it'll end up looking like. All right, so I will be opening the test app that I have for our simple view demo. And you can see here, it's just a plain map. And in the right corner here, this is where our simple widget will be. And you can see it's already rendering some text. So let's jump straight into the code. So what we just saw is this simple widget class. And I'll walk you through it. But basically, this is the boilerplate for creating a custom widget. And I'll walk you through it. So what we're doing here is creating a class that is extending the widget base class. We're assigning a name to our class, and it'll be Esri demo simple widget. Then here we are defining a simple constructor, and we're passing parameters from the base widget class, widget properties. And down below, I'm just defining a render method that is simply creating a div node with hello world as its content. And finally, I export this class. So this is all you need to do to create a custom widget. But let's implement the properties that we mentioned before. So first off, we'll be adding a custom property called enabled, and we mark it as a property using the property decorator. And I don't have a reference to it, so let's go ahead and import it. Now we have an enabled property, and whenever you decorate something with this decorator, it means that the widget will re-render when it's updated. Next up, I will be modifying our render method. And all that I'm doing here is creating a reference to the enabled property. Here I'm defining a classes object, and this helps us apply CSS classes to DOM nodes within your render methods. Right here, I've updated the div node, and we're setting class here by passing the root classes object to the classes utility method. And all this is doing is it will create a class string based on the object. So if we look back, anything that is marked true will be added in the string. So in this case, the base class here will always be set because we're setting it as true. And enabled here will be dynamic, meaning that whenever the enabled property is true, we will apply the enabled class. Finally, I am updating the text that is displayed inside of this node. So whenever the enabled property is true, we'll display enabled, and when it's false, it'll display disabled. Before showing that off, TypeScript is complaining because I have not defined the object here that I'm referencing, so let's go ahead and take care of that. This is a pattern that we use to have a lookup object to reference all the CSS classes that we use in our widget. So we have the base class and the enabled class. So now if I go back to the test app and refresh, now you'll see that the widget says disabled and has a red color for the background. If I click on it, nothing happens because we haven't done that. So let's go back to our widget so that we can change the look by clicking on it. We'll do this by adding a non-click handler to this node. So whenever it is clicked, it's going to call the toggle method, and it's complaining because we have not created it. But let's go ahead and take care of that. Now we have a toggle method that when invoked, it will toggle the value of the enabled property. And just by doing this, the widget should re-render whenever this property changes. Now if I click on it, we'll see it go back and forth between enable and disable and change the background to those different colors. That's it. That is our simple widget view. To recap, we extended the base widget class. We implemented the render method to give the widget a UI. We added a renderable property so that the widget can re-render whenever it's updated. We added an event handler for interaction. We styled the look of the widget by using a utility CSS lookup object for all of our CSS classes. And we toggled the property with the event handler to watch it re-render automatically for us. Now let's take a look at how we can improve our widget. But first off, I'd like to talk about the architecture that we use in the JavaScript API team. We separate our widgets into two pieces, the views and the view models. This allows for separation of concerns, to also allow users to replace the UI, and in the end, to make it easier to integrate into other environments. For views, take the simple widget example. A view typically extends the widget base class. It relies on a view model to define the business logic, and it focuses mostly on the UI part. View models, on the other hand, such as the LayerFX class, extend Accessor, and they provide APIs for a view to consume and to be able to display and update the UI. They mainly focus on the business logic of a widget. So let's take a look at how a view and view model interact. First off, the view will render the state of the view model based on properties and methods. Then, as the user interacts with the view via property or a method in the view, it will cause a view model or a view property or its state to change. Whenever this happens, the view will update, and it renders again based on the state or internal changes. And this repeats during the lifespan of a widget instance. Let's take what we've learned and apply it to create the LayerFX widget. And here's a little preview of what it will look like. Before going into the code, let's take a look at our action plan. So first off, we will be using the LayerFX class as a base to create our view model. It will extend Accessor. It will have a property for a layer, which will be the target for the effects, a property of a collection of predefined effects that we can select and update, a state property that will let us know when the view model is ready to be interacted with. And lastly, a convenience property to get the statements that can be applied to the layer. For the view part, we will be extending widget. We'll add a layer property that will alias to the view model, and we will also define a view model property, pointing to the class from the previous slide. We'll also be rendering the different sections of the LayerFX widget. So with that, let's move on to our demo. All right, I'm going to start our demo and launch our test page. And even if it's not visible, this is already wired up to load and display the widget in the upper right corner, although we don't see it because we haven't started. So let's get to it. This picks up from the previous demos, and I will call your attention to the LayerFX file, which we did in the second demo. This is the same class that Matt created, and this is going to provide the business logic that we want for our widget, so we will be reusing it. We'll only be making a few tweaks. The first off will be to rename it to view model, so it's more consistent with the content that we've been showing. And I'll be adding a state property to support our view. And the purpose of this property is to let our view know when the view model is ready or not. So it does that by checking the layer, whether it has the effect property in it, which we'll need to apply effects to it. And if it's supported and the layer is loaded, it's going to return the ready state. Otherwise, if it's not loaded, it'll be in the loading state, and otherwise it'll be disabled. So that was it for the view model part. since we already had business logic set up. And now we'll move on to our visual part, the layer effects view. And I've set up the base for our layer effects view widget. As you can see, this is very similar to the simple widget class. We are creating our custom widget by extending the widget base class. We have our constructor, and we have a very simple render method. So let's start wiring up our view model to our widget. And we'll start off by adding some custom properties. And these properties are the main layer that we'll be applying our effects to. And this will be an alias of the view model's layer property. And we're doing that by using the alias of decorator. Then we have our messages property, which we use to store all of the text messages that will be rendered in the widget's UI. Lastly, we have the view model, which will provide all that business logic that we just saw. The next step that I want to do is update our constructor to take the additional properties that we just added. Since we already had defined an interface for the previous class, we can just update this type. And if I take a look, you can see that it's just extending the base widget properties and the properties from the layer effects class from the custom layer effects class demo. The next step that I want to do is update my render method so that it actually displays something. I'll do this in multiple parts, but first off, I just want to define the high-level render method. And what this will be doing is applying a set of classes, static classes, to the root node. And referencing that messages property that we just added, we will be showing a title and a summary, and then rendering a container that will host all the individual options for each effect. I haven't defined the render effect method, but what I can do is just remove it so that we can see the progress of this widget. There you go. You can see the beginnings of this new widget. Let's continue by adding the additional render methods that I have here. And there's a couple that I'm bringing in, and I'll walk you through each one of these. But what we've done is separate them into individual ones so they're easier to manage. So for example, if I go back to my main render method, this container will go through the available effects and then render each one of them. An effect, when rendered, it's going to be contained in a field set with a dynamic CSS class that's applied based on the effect's enabled property. Then it will display a legend where it will have a label describing the effect and also a checkbox to enable or disable it. If I go back and check the render effect values method, what this does is it's going to go into the individual values of that effect and render them each. And what this does is it'll produce a set of sliders using the render effect slider label, and it's passing the following properties. And if we go into this method, you can see that it's rendering a label with a name for that value and a slider to update the effect's value property. The last two things that I have pending are some event handlers that are called whenever the checkbox or any of the sliders update. So let's go and bring these in. And what these do is they update the effect's enabled property based on what the checkbox's checked value is. Or if it's a slider, it's going to reference the input slider. And for the respective effect, it's going to create a copy of the values. And then based on the index of the slider, it's going to assign a value to it and update the effect. Now, if I go back to my demo and refresh, we'll see something a little bit more different. So now you can see all the different effects that are supported, along with the values for each of the effects. And I can see all these effects visually as I start enabling them and playing with the sliders. That's pretty cool. And that's the end of our custom layer effects widget demo. Let's recap what we did. We paired a view and view model made specifically for the layer effects widget based on the previous slides and demos. We rendered properties from the view model in the widget view. We wired up interactivity via event handlers. We learned how to apply styles. And we saw how the UI updates based on the value of properties changing. To recap our session, we learned how to set up the dev environment to work with the JavaScript API. We learned some fundamentals from Accessor and then wrote the layer FX class. Then we stepped into the fundamentals of writing a widget, and we learned how to write a simple widget and then take the next step to develop our layer FX widget. After that, we
Here are
enhanced
some additional
the layer
resources
effects
that you
widget
might be interested
by
in
supporting
if you want to take
other
your
locales.
widget development skills to the next level.
All these are links from the JavaScript SDK, and you can access all of these if you take a look at the slides that we'll be sharing later on. Additionally, here are some other sessions that you might be interested in if you want to learn more about widget development. If you have any questions, such as where can I find the slides and source, or if you would like to submit a question, please check out the following bit.ly links. And this concludes our session. Thank you.
Hello, thank you for watching our session. We got some great questions from you guys during the session, so we'll take some time to go through those and get some answers for you guys. So the first one we have is from Jack. Is there a way to access the unminified version of Esri's code for their existing widgets?
Yes, yes for the widget views. The rest of the code is not unminified because it is not open source, but you can access the unminified widget views by going to GitHub under the Esri org, and then type in ArcGIS API. There should be a for master branch, and then you can just navigate the path. I believe it's Esri, and then widgets, and then you'll have access to all the TSX files.
Perfect. Thanks, Franco. Next question from Paul. When would building your own custom widget in a JS API application be a better option than a custom widget in Experience Builder?
I would say it depends on the use case. If you are already in an Experience Builder environment and are producing apps using Experience Builder, it makes total sense to keep using that to create your own custom widgets. If you want something that will work outside of that, it might be a good option to use the JS API to create a custom widget that you can start using in other frameworks, for example.
Yep, that makes sense. So if you're only using Experience Builder, then you can build the widget there. Otherwise, if you want to use it in anything with the JavaScript API, build it there. Thanks, Franco. Next question from Anthony. Is there an application sample where Esri that incorporates a custom or extended widget that doesn't use window.dojo config to import packages?
Not at the moment, but I think we should have something soonish because as of 4.19, the ES module build is going out of beta, and therefore the ES module build, I think we don't have an updated custom widget sample for that. So that would make it easier to show how you can import the modules without using Dojo, for example.
Yep, makes sense. Okay, next question from Chris Rogers. How often is the JavaScript API updated and at what frequency? Is it kept current with the JS standard?
The JS API is released and updated it's updated quarterly throughout the year. And in terms of how it is kept current with the JS standard, if I understand that correctly, the JS standards are updated every year, released. I'm not clear on that, but in terms of using the latest standard, we try to be as modern as possible, but there's no official rule that will always be on the latest.
Perfect. Next question, are the samples from today's session, and I think it's asking, how can we get the samples from today's session and how to create a widget in general available on GitHub?
Gotcha. There is a bit.ly link for everything that we showed in today's session. So if you go to bit.ly/buildwidgetsds21, it'll take you right there.
Yes, and I created an announcement, so it should be in that announcement on the Slido chat as well.
Perfect. Thank you.
Cool. Next question. What should be the approach to convert custom GP tasks into a widget? Do you have any examples?
We don't have any examples specifically for that, but from a general approach, I would consider creating a class that will store all the GP, access to the GP tasks using the Esri geoprocessor module. And once you have that class that has all the methods to invoke the GP task and then process the results and store them, you can start writing a widget view that would access, for example, it could have a button there that when you click on it, it actually invokes the GP task. And when it resolves, the widget can now just start displaying results. That's just from a very generic perspective. If you want more help on that, I would suggest reaching out to the Ask Our Experts showcase in the web development channel.
Yes, good point. All right, next question. Will these sessions be available to watch again after the summit has ended?
I think they should be.
I believe they should be available after this is done recording to be viewed again. So you should be able to watch them. Next question. In this example, how would you add a widget such as a base map, gallery, or measurement widget? I think it's referring to like rendering widgets within another widget.
Sorry, just going back to the other question. Yes, the recordings will be available in the platform.
Cool.
In terms of how to reuse an existing widget in a custom one, is the approach we have right now is to create variables that store instances of these widgets. And then inside of a render method, for example, of your parent or custom widget, you would call render from these supporting widgets so that they display inside. And if you need to invoke any of the APIs, you just call them directly on the instances that you have references to. And that's the current approach that we have right now, but I think we have some stuff coming in one of the future releases that should make this process much simpler. To just use JSX, put in your one of the existing widgets, and then have it be there.
Yep, that'll hopefully get simpler in the next release or two. So thanks, Franco. Next question from Chris. Other than the ability to use a custom or to use a widget in multiple JS apps, are there other benefits of using widgets rather than Dojo or another API?
Let's see. If you want something that is using the Esri ecosystem, that's one option, what you would want to create a custom widget here. But it's really up to what makes you a more effective developer. If you have a framework that you like for creating widgets, you can totally stay with that as long as you stay productive and doesn't really hinder your progress.
Yeah, I would say it's up to them, up to the developer for what they're comfortable in. If they're already developing in the Esri framework, then it would make sense to do that, but it's really flexible. So it's up to you guys. Cool. Next question. What happens after the JavaScript API 3.x is retired?
That's a good question. I guess once the 4x reaches parity, 3x will be marked as retired, and then I believe there will be a few cycles where critical patches are still going to be made available. What happens outside of that, I'm not too sure about. You can maybe reach out at the Ask Our Experts showcase, see if they have a better answer.
Yeah, I think it's just mainly that, development will pretty much stop unless critical patches are needed. And critical patches being like browsers, change and things break. But as far as like, they'll still be available on the CDN, so they're not going to be like wiped clean or anything like that. So you'll still be able to use and access them. Cool. Next question: does the JavaScript garbage collector do a good job at keeping the memory scope clean, or does the widget developer have to init and destroy everything when no longer needed?
So browsers have been getting better at garbage collection in general, but it's usually best practice for you in your widget to set up and tear down responsibly. So any sort of resources that you have there, if you have something that's fetching resources, making requests every few seconds, once it's torn down, you should just cancel that so the browser has more resources for the rest of the app.
Yeah, I think it's just a best practice. So you don't want to have any memory leaks and stuff. So yeah, it's good to do that. Thanks, Franco. Next question. It would be great if you could open source the view models. Developers would benefit a lot. What do you think?
That's a good note. We can pass that along.
Yeah, we'll pass it along and see what we can do, but yeah. What is the difference between a TSX and TS file?
The difference is that the TSX file lets TypeScript know that there is JSX inside of the file. So if you were to copy a snippet of JSX into a TS, you'll get all sorts of syntax errors. So by having that X in the file extension, it lets TypeScript know, okay, there's some JSX here. I should know how to read it.
Yep, perfect.
That's basically it.
Yeah. Is the widget pattern you outlined today compatible with the development pattern of Calcite Web Components? I'm specifically curious about the compatibility of JSX with custom elements.
I mean, the Calcite components are compatible with JSX. The examples that we showed, the example code has Calcite components inside of the, actually, no, I take that back. We do that in the customizing widget session. And from the browser's perspective, it's just another tag there. So it is completely compatible with JSX. If you do want typings, that's also supported because the Calcite components support TypeScript. They have their associated typings that you can just pull into your project. And yeah, I will give you hints at what each tag supports.
Yep, so because they're just custom elements, they should work perfectly. So should be good there. Next question, when would using the destroy method be necessary? I noticed the samples don't implement it.
That's a good question. I believe it's more for anyone that is creating that widget. For example, in our custom widget, there's no parent code that is creating it and then needs to swap out to like a different view or something like that. If that were the case, that's where you would typically see a destroy happening there. Just letting know that, okay, I no longer need this widget. The app can start moving resources to create some other stuff.
Yeah, it kind of goes back to the garbage collection thing. Some of the widgets don't really create any listeners. They need to clean up and destroy. So you won't see those there, but in other widgets, they do. And even internally in the widget class that you extend to create a widget, there is a destroy method that kind of cleans up some stuff. So you may not see it in every widget, but it's there for what is needed. Cool. Is it possible to develop a widget with your own JSX factory and a React app at the same time?
I believe this is possible by using JSX Pragma in TypeScript. It's a pattern using comments that lets TypeScript know which JSX factory to use for a specific file. So I think that could help you with having multiple JSX factories.
Yep, perfect. When and when not to use the renderable decorator annotation?
That's an excellent question because as of, I believe, 418 or 419, all the properties are now automatically renderable. So you no longer need to use the renderable annotation, meaning that any sort of property that was accessed during a widget render, it's automatically marked as renderable. So making it easier for you as a developer.
Cool. Thanks, Franco. What version of JavaScript are you considering modern?
I think ES 2019 might be the latest one we're using, but I can double check that. If you reach out at the Showcase channel, we can get you an answer for that.
Sounds good. And then how do you get past not including the file extension in your import statement?
Okay, that is because of the way TypeScript resolves imports. It'll implicitly add different extensions and try to look up the modules. It's how TypeScript works.
Cool. I think we're out of time, so we have a few other questions that didn't get answered, but we'll try to answer them in the chat. But thank you guys for attending our session. And don't forget to rate us.